Okay, welcome to the video. So this time we will learn about Quick Python and DuckDB data processing. And this tutorial would be focusing on the how, not the what or why, uh, but just two reasons on why we use DuckDB. Because the first, it is in process database management, so meaning that we can access dataset or data frame uh, under some programming environment or already loaded into the memory, because it will directly access the data from the memory. And secondly, we don't need to install any server. It is not like other database management systems such as SQL Server, MySQL, or PostgreSQL, which need us to install some server before we're started to use this kind of database management system to do the data processing. And later on we need to import the data set into the server, and we need to fire the database client and do the processing. So we skip many things, many steps, many process using this DuckDB. And why we don't use the SQLite? Because yeah, SQLite is a single file database, and it also doesn't need us to install any server. It is very easy and quick way to do the SQL things. But yeah, it is not in process database management, so you can see all the details on the respective website. You can just search in Google or Bing or anything, DuckDuckGo, about the DuckDB. Okay, so actually there are 7 steps here. Yeah, step 0 would be put all files in one folder, because it will save our work later on, because we don't need to worry about the absolute path, relative path, and we don't need to deal with weird folder naming system, forward slash or backward slash between Windows or Mac or Linux. But we're just working on all files in one folder. So yeah, that's pretty much it. And here we go to the step 1, that is the install requirement. We can use the pip. Yeah, so this tutorial will assume that you already know or familiar with Python environment. So it is totally up to you whether you are using Miniconda or Anaconda or Miniforge, Mamba Forge, and so on and so forth, pipe and pn, no matter what. So as long as you have a working Python environment, Python version 3 or later, so we can start this tutorial. It should be like this. You can install one by one, or all the required packets at once, such as pip install pandas, DuckDB, PyRedstat, OpenPixel. So pandas is a library for dealing with data frame easily, and yeah, it has many features. So you can also googling on the why and what. And so the DuckDB and PyRedstat is basically two open many formats other than text file. For example, using PyRedstat, we can open SAS dataset or stata dataset, or yeah, basically I use this PyRedstat to open the SAS and stata data files. And also SPSS, we can also use the PyRedstat to open the dataset. And last but not least is the OpenPixel. It is to load or to read the Excel file, right? So once we install this, we can import pandas, right? Pandas, and also DuckDB. Import DuckDB, and we also from pirate stat, from pirate stat we must read DTA, read SAS, BDAT, and also read SAF. Yeah, something like this. So here I have a kind of different files here. For example, we have this DTA and also Excels, right? And also CSV, but we will focusing on the DTA because this is the unusual format, at least for some people who don't familiar with this stata things, right? So okay, so the first thing is I want to load the using this one. TP means just use any variable you want. For example, this TP and meta. One should be the meta should be placeholder for the metadata from the stata file, because in stata you have the variable types and variable labels and yeah, metadata regarding the content within the table, right? So we use this one to load the DTA file into the TP and meta one, and then we also load the TL, right, and meta2 from other table or other file. This one is reference, right? TL means reference, and the TP means uh, kind of primary healthcare, or yeah, the lower class of the first encounter for hospitalization. So but for TL means that some people who needs a further treatment, he or she need to go the more advanced facility, so it would be included in this TL. So basically we need to link between the TP and TL based on the patient registration number, and yeah, so we have this one TL and TP, so we can check this shape. We have around 5 million point 5 point let's say 5.8 million of rows, and for the TL also around 5 million. So we can quickly check the columns, and also TL, right? TL, and the key between the two table is this one PSTV 001, and yeah, this one is PSTV 01, right? So we need to connect these two tables using this PSTV 01. Okay, so if we check the CSV, we can see that we also have the TM kepesertaan.csv. This is a table for membership, right, for the national health insurance. So using DuckDB, we can query the content of the CSV file directly without importing the file into the dataset or data frame. So we can use something very quick, right? And if we want to, for example, count how many member we have, we can use something like this, PSDV01 count this thing, right? So if we want to select some specific thing, we need to specify the select. Yeah, it has 100 143, yeah, thousands of unique patients, right, for the membership. So for example, yeah, so this is directly we're skipping some step from the step 2 3, right? 3 is already, and now we already in the step 4 to the query, right? Select all from data frame, or select all from, this one is directly from the CSV file, but we can also using this data frame as table, right? We have something like this, and we have another thing from the TL. All the query means counting the distinct column name, right? How many distinct or how many unique columns, or in this case PSDV01, or register number out of every tables, right? So to join, or to do the, some join operation, it is easier for us to create a new table based on the data frame. So let's do that using this create table, right? Membership as from TM CSV. So we can check show tables, right? We have one, so we create another table, TP FTP, let's say FTP from TP. Yeah, for some process it would show this progress bar, right? So you can see what happened if it takes some time. So later on I will also create the table FTL, right? It should be just take some seconds. So in this case we don't need to specify the column name or column format, column type, right? Because in some database management system you need to create the table first and define precisely what the column type. For example, varchar 200, meaning that you have maximum 200 characters as the content from this column, and so on and so forth. But using this pandas and also DuckDB, we don't need to specify the column name and column types, right? It is very straightforward. Just load your data set or your data file into the data frame, and then create a table based on those imported data sets, and we are good to go. So if we check the tables, we already have 3 tables, right? So we can just delete the TP and also the TL to free some memory. So we're, from now on we only use the table from the DuckDB database, right? So for example, I can select all from FTL, right? It's very fast. And if I want to create some data frame out of the query, I can use this df, right? Df, it should be some converting the output into the data frame format. But maybe if you don't limit the query, it will take some times, right? So yeah, so we need to be careful on this conversion to data frame format. So this one we have, yeah, 5 millions, 5 something millions and 55 columns. and it takes some seconds to query all the rows and convert to the data frame. It is much faster than loading the data from the DTA or the CSV, or yeah, any external file format. So we can start joining the table. For example, I want to join the membership table and FTP, right? Or I want to find the 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 patient from FTP that is connected to FTL based on the PSDV01, right? So I can do something like this. Select let's P all and T all from FTP SP. We can use left join or just join, right? Or join FTL as T on P S TV01 equals to TPS TV01, right? So we can so it means that querying across to 5 million rows just taking very quickly. So I want to know how many visits. It is actually visits, not necessarily unique patients, right? Because we don't specify any grouping or any distinct selection here. Yeah, but of course, if I use the DF, it would take much more times than just displaying the output. Well, if takes some time, I just use the, we cannot use the Control C, right, to stop the process. Okay, I just stopped the process because it takes so long time to generate the data frame. So it doesn't necessary for us to convert everything to data frame. So we can use the other way to know how much connected patient between TP and TL. One of them is, I can use something like this, select count. Still we can use distinct PSTV01, right, from FTP. We can use S or omit the S, right? We can use this one or just this one. Join FTL L on P PSTV01 equals to L PSTV01. Yeah, if it, oh, not really long. So we have to 8,000 something patient connected, right? So, and we have something like this one before. Count distinct TP. So almost all the patient from the first hospital or primary healthcare would go to the advanced treatment for hospitalization, or yeah, for treatment. So So if we see how many patients, yeah, just 1000 of the TL visits are not, or were not coming from the TP, right? So that is how to count and connect this. This one is on how we do the operation between two tables using the join based on keys, right? And we can also use some feature from the uh, DuckDB to do the filtering. For example, I only want to select some specific rows containing some specific information. So let's see the columns. So for example, FTP, I will leave it by 5, and I just want to check the columns. So I will focus on this FKP something, right? Because it should contain the diagnosis information. So I can select, although in this case the case all caps or capitals, we can use both capital or lowercase or uppercase. It is no problem because we're using the SQL, right? So I can use this one instead of this one. Using both is okay. STV01 and then FKP 14, FKP 14A, FKP 16, FKP 17, FTL limit. FKP 14. Oh, FTP, right? FTP. So this is not what we are expecting, so we can use something like where, right? Where, because mostly they were empty, so we can use something like FKP 14 doesn't equal with 9999. Right, so we have A000, right? FKP 14. So this is actually the FKP 14A would be ICD 10, 3-digit of ICD 10. So later on I can use this, like for example K, dental cases, dental, yeah, K00 or J something, or A9 dengue fever, right, for A90. So we can also just remove this one and we can count this thing, how many patients diagnosed with this diagnosed, right? So we have 1000, so we can also see the every diagnose. In this case, we don't need to use a limit group by FKP for FKP 14A. So we have this number. So it would be very quick, right, to do some quick demographic check or epidemiologic check of the numbers of the patient from this FTP. The same would be also applied to the FTL if we want to, right? But that's the idea. So you can use the either using this one. Like means it's not really precise code. So meaning like means you need to use, for example, if I just use this one, it should be only one, right? But if I use the percentage sign, it would replace the last uh, the last digit or last sequence as anything. We just specify the A9. What happen if we specify just A? It should be something like this. All of ICD 10 code prefixes with A would be displayed, selected, and count the number of patients of each of those codes, right? So we have 86 rows or 86 different ICD 10 prefixes with A code. So the same would be for P. Yeah, this is totally up to you. So here are the basic one. So we can do the sample or the sampling or the filtering, right, using the where. We can also use the in a 90. Just want to focus on these two, right? So we have almost 800 patient for A90 and A91. So how about we create a subset, a new table based on this one, right? So we only want to create the, let's say, outcome tables, right? Outcome tables. So we PSTV 01. I just want to select all patient group by PSTV 01. So we have here 700 something PSTV. Actually, we don't need to use the group by, right? Because we already used this thing. We have something like this, and we want to create a table, right? The same. We get table outcome DHFS, and if we check the show tables, we have now the outcome DHF. So usually I do this from pandas. For example, this one we can also use the pandas way. because we only have a small subset of the data, so it is okay to convert the data to the data frame format. So we have the out, right? We have the out, and we can just use the we can specify the other properties from other table later on. For example, I want to add the age column, right? Age would be default. I just put the 0 here, and gender would be 0, means female, right, by default. And also, yes, something like this. For example, I can see we have this kind of and we can also check the dp from mem order by random, meanings I randomly selected 5 rows from the main, something like this. And yeah, for example, columns, I'm not sure really, but let's say that the gender is the PSTV05. Actually, we can check the documentation. Let's see, we have the metadata here, but that's okay. I just want to update this one using the information from the membership table, right? So I can use I will drop the outcome first. No, outcome DHF, outcome DHF. Okay, so I want to query the because I want to update, because the idea is you can use something like this. Out hypertension, right, would be 0, right? No HY, but HD. And for example, DM, although it is actually from DM databases, but anyway, we can just set everything to 0 first, right? DM also, for example, what its IV would be 0. It's just up to us, right? We can update the information from other databases, but in this case I just want to update the, for example, the gender, right? For the gender from the PSTV05 from membership table. So I can do the thing using something like this one. Update outset gender would be select PSTV05 from mem where out PSTV01 equals to mem PSTV01, for example, something like this. Oh, you can only update this table, meaning that for update we need to import the outcome to the table. So okay, so we can create this one, this the table SQL, create outcome dengue high fever as from out, right? Create table. So later on we can use this one, outcome DHF and outcome outcome DHF. Yeah, so if we select all from outcome DHF, should be something like this: 1 2 1 2 1 based on the information from the. Okay, so how to update other table or not other table, other column as well from information from for example from FTP in this case, right? So if, for example, if I want to update the for example HD hypertension, I should do something like this one, right? And I need to select the which patient, right? Which patient, BSTV01 in, right? Because in this case I want to select all the distinct BSTV from FTL, where in this case we don't need to specify the ID, right? The patient ID or BSTV01, but we want to filter or want to query the specific ICT 10, for example. But I'm not sure what the code, but I just use some random, right? Some random. This one is actually for respiratory things, right? Respiratory thing. Oh, for example, I use something like this one, like for example, I just want to update something like this. But later on you need to check what the code for the hypertension. This is just for sample. So for example, I run this one and FTP, not FTL, FTP. So if we check the select all from outcome DHF where DM equals to 1, we don't have, right? We don't have anything. So we can use, for example, just use something like this: A0 FTP, or not DM but HD, right? Okay, so we have something like this one, not DM but HD. Okay, so you got the idea, right? So to update some specific column, we need to which patient have this kind of condition, right? And we then update that condition with 1, otherwise it would be 0. Yeah, so later on we can have this some and you should remember that this is only for the outcome tables, but later on you can also create the new another table as non-outcome, right? Because we need to compare the outcome and non-outcome using the same steps or same principle, right? So you can later on join the two tables, outcome non-outcome, into one unified table ready to be processed on statistical analysis or machine learning or anything. Yeah, I think that's basically pretty much it, and bye bye.